Good morning, everyone. My name is Muhammad Ariel Praditya and today I will present a research article that titled Implementation of a Three-Phase Motor Protection System using PLC and HME. It published in 2024 in the International Journal of Multidisciplinary Approach Research and Science. The authors are Yuli Prasetyo and colleagues. First, I will explain about the introduction of the article. So, three-phase electric motors are very important in industrial environments. They are used in pumps, compressor, conveyor, and many other heavy machines. However, these motors are vulnerable to electrical disturbance, such as high starting current, overcurrent, and short circuits. If these problems are not handled properly, they can cause motor damage, production downtime, and financial losses. Because of this, an effective protection system is necessary. Now that we understand the background of the study and its importance in industrial application, let us move to the main objective of this research. Alright. The main objective of this research is to develop and implement a protection system for three-phase electric motors. Three-phase motors are widely used in industry, but they are vulnerable to electrical disturbances. The system is designed to protect the motor from high starting current, overcurrent, and short circuits. The researchers use PLC for control and monitoring, and HME for operator interface and visualization. The overall goal is to reduce motor damage and minimize production downtime. To achieve this objective, the researchers design and test a protection system. Let me explain the method they use. Okay, so this research used a system testing approach. The protection system was designed using a programmable logic controller or PLC, a human machine interface or HMI. The testing stage include test planning, test design, test execution, monitoring and reporting, evaluation, and bug fixing and retesting. And for data collections, the motor was tested under no load condition and full load condition. The current values are measured and compared to the set limit of 0.5 ampere. Then the system response was observed whether it stayed on or turned off. After conducting this test, the researchers obtained important findings. Let us look at the results. Now, let's look at the key findings shown in the chart. The protection setting was 0.5 ampere when the current was 0.2 ampere and 0.4 ampere, which are below the limit. The system stayed on. This means the motor operates normally. However, when the current increased to 0.6 ampere and 0.8 ampere, which are above the limit, the system turned off automatically. The protection setting was 0.5 ampere. When the current was below 0.5 ampere, the system stayed on. This means the motor operates normally. When the current exceeds 0.5 ampere, the system turned off automatically. Overcurrent conditions were detected at 0.6 and 0.8 ampere. In this case, the PLC successfully shut down the motor to prevent damage. The HME also displays real-time monitoring, allowing operators to observe motor condition clearly. From these results, we can now draw some conclusions. In conclusion, the PLC and HME based protection system works efficiently. The system can quickly detect overcurrent conditions and automatically prevent motor damage. It improves the reliability of three-phase motor in industrial environments. And the implications of the research are: first, it reduces industrial downtime. Second, it enhances equipment safety. Third, it supports industrial automation development. And the last, it can be implemented in factories using heavy machinery. Finally, I would like to share a short personal reflection about this article. So this article is relevant because it is very useful for automation and control engineering students. And it combines theoretical concept of motor protection with practical industrial implementation. It shows the importance of smart protection systems in Industry 4.0. It also demonstrates real industrial applications of PLC technology. This research is related to renewable energy because renewable energy systems such as wind, hydro, and solar power plants use three-phase electrical machines and motor. These systems are sensitive to electrical disturbances like overcurrent and short circuits. The PLC and HME-based protection system in the study can improve reliability, safety, and efficiency of renewable energy installation by preventing equipment damage and reducing downtime. So that concludes my presentations. Thank you, and thank you very much for your attention.